The future is always an exciting topic. Some people try to predict it, but predictions are almost always wrong. Technology moves fast, and there's a lot that we don't know about the future. In this video, we will explore some of the latest developments in missile technology and find out how the way that missiles are going to be used might change by 2025. Before we begin, don't forget to hit that like button for more videos. Now, let's get started. However, one thing that we do know is that missiles will play a big role in how wars are fought in the coming years. But just how will they be used? In recent years, several companies and militaries have unveiled new missiles that use AI to navigate to their target. For example, the U.S. Army has developed the Precision Fires Rocket Launched Unmanned Air Vehicle, or a rocket-launched unmanned air vehicle that uses AI to identify and track targets. The PRU is designed to be deployed from a standard artillery tube and can be used to attack moving targets in a variety of environments. Similarly, the U.S. Navy has developed the Naval Strike Missile, a long-range anti-ship missile that uses AI to navigate to its target. This is due to the development of new missile technologies such as hypersonic missiles, which are difficult to intercept. These smaller strikes would allow militaries to achieve their objectives without risking the same level of collateral damage that would result from a large-scale missile attack. This figure represents the radius of a circle in which 70% of the test missiles landed. For instance, machine learning algorithms can learn from past missile launches and adjust the guidance parameters accordingly, resulting in greater accuracy. Moreover, these algorithms can adapt to changing conditions during the flight of the missile, such as wind speed and direction, which can cause deviations from the intended trajectory. Another approach involves using advanced guidance and control systems that incorporate machine learning algorithms to optimize the missile's trajectory and compensate for external factors, such as wind speed and direction. Additionally, the use of real-time target tracking and data link technology enables the missile to engage moving targets and respond to changes in the target's position during the missile's flight. To evaluate the accuracy of missile targeting, various metrics are employed, but also on various operational factors such as target selection, mission planning, and the effectiveness of the warhead. However, despite technological advancements, questions remain about the reliability and safety of missile targeting. International cooperation and transparency are essential to build trust in missile targeting systems and ensure responsible use in armed conflicts. Open communication channels between nations can help alleviate concerns and promote confidence in the accuracy and safety of missile targeting. Additionally, independent verification and monitoring mechanisms can be established to observe missile tests and combat operations, providing assurance that PGMs are being used in accordance with international norms and standards. Furthermore, investment in research and development of advanced targeting technologies such as AI-powered systems can enhance the accuracy and reliability of missile guidance, reducing the risk of off-course strikes. By addressing these concerns and promoting international cooperation, the international community can work toward establishing trust in missile targeting and ensuring its safe and effective use in modern warfare. There are concerns that missile guidance systems can be compromised due to factors such as electronic warfare or hacking, potentially causing them to veer off course and strike unintended targets. Additionally, the use of PGMs raises ethical concerns, as it allows for more selective targeting of military installations while minimizing harm to civilians. However, critics argue that this could lead to a blurring of the lines between legitimate military targets and civilian areas, potentially resulting in the violation of international law and the displacement of civilian populations. Nevertheless, the pursuit of greater accuracy in missile targeting remains an important objective for military organizations and defense contractors worldwide. Can we trust missile targeting? One common method is the circular probable deviation, or C, which represents the radius of the circle within which 50% of the missiles are expected to land during a test. Another metric is the root mean square deviation, or RMSD, which measures the standard deviation of the missile's impact points from the target center. These metrics provide a quantitative assessment of the accuracy and reliability of the missile targeting system. By adjusting the guidance parameters in real time, machine learning algorithms can compensate for these external factors and improve the accuracy of the missile. As technology evolves, we can expect to see even more sophisticated and precise targeting systems in the future. First, there's the accuracy of the intelligence, or MINT, used to identify and locate the target. If the target location data is inaccurate, then the missile will not hit the intended target. Second, there's the launch platform's stability and accuracy. If the missile is launched from an unstable platform, such as a ship at sea, then the missile's trajectory will be affected and its accuracy will be reduced. Third, there's the missile's own internal mechanisms and components. Any inaccuracy in the missile's guidance system, warhead, or other components can affect its overall accuracy. And fourth, external factors such as weather, temperature, and humidity can also impact the missile's trajectory and accuracy. To mitigate these factors, several measures can be taken. For instance, improving the accuracy of target location data through better intelligence gathering and analysis, using advanced launch platforms and technologies such as inertial measurement units and GPS to ensure a stable and accurate launch, employing advanced guidance systems and components that minimize internal sources of inaccuracy, and finally, conducting rigorous testing and simulations to evaluate the impact of external factors and develop mitigation strategies. Despite these efforts, it is important to note that achieving perfect accuracy in missile targeting is virtually impossible due to the complexity and unpredictability of real-world conditions. Therefore, the goal is to strive for the highest possible level of accuracy while considering the cost, time, and technological limitations of each specific situation. Additionally, machine learning can help to reduce the cost of missile testing, because the algorithms can learn from simulated data rather than requiring physical testing of the missile. This can significantly speed up the development and deployment of new missiles. In the case of the MGM-164 Tomahawk missile, the CPD was only 1 meter, indicating exceptional accuracy. The increasing demand for greater accuracy in missile targeting has led to the development of new technologies and approaches. The Naval Strike Missile is designed to be launched from ships and submarines and can be used to engage enemy ships and aircraft. As AI and machine learning continue to develop, we can expect to see even more sophisticated targeting systems in the years to come. The desire for greater accuracy in missile targeting stems from several factors. First, it improves the effectiveness of the weapon system by ensuring that the missile hits the intended target with greater precision. This reduces the likelihood of civilian casualties and collateral damage, which can occur when a missile misses its target and strikes nearby buildings, infrastructure, or personnel. It also minimizes the risk to the operator or launch platform by reducing the possibility of fratricide, which occurs when a missile misfires and strikes friendly forces. Furthermore, high accuracy reduces the required number of missiles to engage a target, minimizing the overall cost of the operation. It also enables new military capabilities, such as the ability to engage moving targets and perform rapid target switching. In response to the demand for greater accuracy, missile manufacturers and research institutions have developed various technologies and approaches. The use of AI-powered missiles is likely to become more widespread as these systems offer a number of advantages over traditional missiles. As a result, we can expect to see missiles being used in a wider range of scenarios, including in urban areas and against moving targets. Another possible change is that missiles will be used in conjunction with other types of weapons and military equipment. For example, missiles could be used in conjunction with drones to create a more comprehensive and effective attack. This would allow militaries to gather intelligence on their target, and then use missiles to deliver a precise strike. And finally, we may see a shift away from large-scale missile attacks in favor of smaller, more targeted strikes. This is due to the development of new missile technologies such as hypersonic missiles, which are difficult to intercept. These smaller strikes would allow militaries to achieve their objectives without risking the same level of collateral damage that would result from a large-scale missile attack. Overall, the future of precision-guided munitions is looking bright, with advances in technology leading to more accurate, effective, and versatile weapons. As AI and machine learning continue to develop, we can expect to see even more sophisticated targeting systems in the years to come. AI algorithms can process information from a variety of sources and make real-time adjustments to ensure that the missile hits its target. As AI algorithms continue to improve, we can expect to see even more accurate and sophisticated missiles in the future. As missile technology becomes more advanced and sophisticated, militaries around the world will be tempted to use them more often. Additionally, the use of AI-powered missiles is likely to become more widespread as these systems offer a number of advantages over traditional missiles. As a result, we can expect to see missiles being used in a wider range of scenarios, including in urban areas and against moving targets. So, how will all of this affect the way that missiles are used in 2025? For example, missiles could be used in conjunction with drones to create a more comprehensive and effective attack. This would allow militaries to gather intelligence on their target, and then use missiles to deliver a precise strike. Well, it's difficult to say for sure, but we can make some educated guesses based on current trends and developments. Second, they will be less vulnerable to jamming and other forms of electronic warfare. Because they don't rely on external systems. AI-powered missiles will be able to navigate to their target, even if GPS is unavailable or inaccurate. And third, they will be more flexible. AI-powered missiles can be reprogrammed in flight to change their target or course of action. This makes them ideal for use in dynamic or evolving situations. Hello, and welcome to our channel. So what exactly is missile targeting, and why does it matter? Well, the most advanced missiles today rely heavily on satellite navigation systems, such as GPS, to guide them towards their target. These systems are accurate, but they're not perfect, and they can be disrupted or even hacked. One of the biggest challenges is ensuring the safety and security of these systems. AI algorithms can be hacked or manipulated, which could lead to catastrophic consequences. Therefore, it's essential that these systems are designed with robust cybersecurity measures in place. Another challenge is the need for massive amounts of data to train AI algorithms. These algorithms need to be fed with huge amounts of data so that they can learn to identify and track targets accurately. This raises concerns about privacy and the potential for misuse of personal data. Finally, the use of AI-powered missiles raises ethical questions about the role of humans in warfare. If machines are able to navigate and strike targets, what role will humans play? That's why many militaries are now developing new missile targeting technologies that don't rely on GPS or other external systems. Instead, these new missiles will use artificial intelligence, or AI, to navigate to their target. AI-powered missiles will have a number of advantages over GPS-guided missiles. First, they will be much more accurate. But the development of AI-powered missiles is not without its challenges. Despite these challenges, the development of AI-powered missiles is progressing rapidly. These developments indicate a growing trend toward the use of AI in missile technology. One of the most likely changes is that missiles will be used more frequently and in a wider variety of situations. Another possible change is that missiles will be used in conjunction with other types of weapons and military equipment. And finally, we may see a shift away from large-scale missile attacks in favor of smaller, more targeted strikes. Overall, the future of precision-guided munitions is bright, with advances in technology leading to more accurate, effective, and versatile weapons. One way to measure the accuracy of a missile is by the circular probable deviation, or CP. One example of this is the use of machine learning algorithms to improve missile guidance. Machine learning offers several advantages over traditional guidance systems. As missile technology continues to advance, there is a constant race to develop more accurate and effective targeting capabilities. One example is the use of advanced materials and manufacturing processes to improve the aerodynamic stability and structural integrity of the missile, which reduces external influences and enhances accuracy. The race for accuracy in missile targeting is an ongoing process with continuous improvements and advancements. But how accurate can we get? It turns out that the accuracy of a missile is ultimately limited by several key factors. Ultimately, the success of a missile strike depends not only on its accuracy. In modern warfare, there's been a significant shift toward precision-guided munitions, or PGMs, which are designed to minimize collateral damage by striking targets with greater accuracy. To address these concerns, it's crucial to establish clear guidelines and regulations for the development and deployment of PGMs.